Hello everyone, my name is Angie Poggi, and in this video I will discuss t-tests for two independent samples using StatCrunch. In my previous video, I discussed one sample t-test, which is used to compare or determine whether a sample is from a particular population based on the mean. However, sometimes we will need to find out whether there is a difference in the mean of a variable of interest between two groups that are independent of one another. Two samples are independent when each subject or observation in the first sample is independent or not related to any of the observations in the second sample. T-test makes the major assumption that the amount of variability in each of the two groups is equal. This is known as the homogeneity of variance assumption. We can have three scenarios when using the t-test. The first scenario is that the population variance for both groups are known. In this case, you will use the population variance of each group to calculate the standard error. Unfortunately, the population variance in general is unknown and must be estimated from the data. So that brings us to our second and third scenarios. The second scenario is when we have unknown population variances but equal sample variances. This is when we will use the pool estimate of the variance. And last, our third scenario is when the population variances are unknown and we have unequal or different sample variances, which is the one we are going to discuss now. Let's discuss the steps involved in the t-test with an example. The exercise reads as follows. Investigators want to know whether there are differences in the mean glucose level 2 hours after eating between men and women in a sample of adults under a new treatment of diabetes. The mean glucose level in a sample of 15 men is 108 milligrams over deciliter with a sample deviation of 10 milligrams over deciliter. In a sample of 24 women, the mean glucose level is 115 milligrams over deciliter with a standard deviation of 5 milligrams over deciliter. Now let's discuss the steps to answer this research question. Number 1, state the hypothesis. The null hypothesis is mu1 equals mu2. The two-tailed alternative hypothesis is mu1 not equal mu2, where mu1 is the mean glucose level for men and mu2 is the mean glucose level for women. Number 2, compute the test statistic. The test statistic is the mean of group 1 minus the mean of group 2 divided by the standard error. In this case, 108 minus 115 divided by the square root of the sum of 10 to the power 2 divided by 15 and 5 to the power of 2 divided by 24. This gives us minus 7 divided by the square root of 7.708 equals minus 7 divided by 2.776, which is negative 2.521. Number 3, compute the approximate degrees of freedom. There are several ways to calculate the degrees of freedom associated to the t-test. In our case, our degrees of freedom is 18, which can be calculated using the formula. Number 4, obtain the p-value from a table or a statistical software. Remember that depending on the table, you may have to multiply the probability of the t-stat times 2 to get the probability in two tails. In our example, the p-value is 0.02. Number 5, interpret the result, comparing the p-value and the significance level, and draw conclusions based on the research question. Remember that if the obtained p-value is less than 0.05, then we can reject the null hypothesis. Otherwise, we cannot reject the null hypothesis. With a p-value of 0.02, we can reject the null hypothesis because it's less than 0.05. We're 95% confident that the mean glucose level for men is statistically significantly different than the mean glucose level for women 2 hours after eating with the new treatment for diabetes. In StatCrunch, you will click over Stat, T-stat, to sample with summary, because the exercise provides us with the summary statistics. You will then enter the statistics, mean, standard deviation, and sample size for each group or sample. StatCrunch gives us the calculation option of pool variances. The default is off. You can check this box when the variances are equal. In this exercise, the variances are not equal. Under Perform, you will select Hypothesis Test for mu1 minus mu2. Because we want to know whether the two mean are different, we will leave the 0. Note that you can change the direction of the alternative hypothesis depending on the research question. In our example, we want to determine whether the means are different or not, so we will keep the not equal sign. Our last step is to click on Compute. The output shows the p-value of 0.0211, which is less than 0.05. Therefore, we can reject the null hypothesis. Again, we're 95% confident that the mean glucose level for men is statistically significantly different than the mean glucose level for women 2 hours after eating with the new treatment for diabetes. Hey guys, when you're analyzing data in StatCrunch, that is if you have a data set with variables of interest, you will select with data under the t-test options. For each sample, you must indicate the variable of interest, which should be a quantitative variable. And you must also specify the group under the where statement using the categorical variable. To do so, click on Building. The expression window will pop up. Identify the specific groups with the qualitative variable. The expression at the top will populate and you will click on OK. Under Sample 2, you will follow the same steps for specifying the other group of interest. You will then select hypothesis test for mu1 minus mu2 and some optional graphs such as box plots or histograms to better describe or understand the mean differences between the two groups. Finally, you will click on Compute. The output will be similar to the other t-test.